So if we were interested in, having this binary variable of female or perhaps a binary variable of male in our regression, we can put one or the other in our regression. So we could either think of maybe having a regression that is wage equals beta 0 plus beta 1 times education plus delta 0 female plus U. Or we can think about having wage equals beta 0 plus beta 1 education plus delta 0. And, we could do it the other way and have a variable male. But in either case, we got to leave out one of the groups. And the reason why we need to, I'll put 3 down and I'll write down what would happen if we put both the groups in. And the reason why we need to leave out one of the groups is that perfect multicollinearity problem that we've talked about before. So let's say we had delta 0 female plus delta 1 male plus U. This third regression suffers from perfect multicollinearity. In particular, this variable, female plus male, they had to either identify as female, assuming you have to identify as one of these two things. You either have to identify as female or identify as male. Add those two things together, you always get 1. If someone has to identify as male or female. Because female, this variable female plus male equals 1 if they have to identify as one of the two. And remember, 1 is like kind of this x0, kind of part of our intercept, right? It's like a 1 for every single person. So when you use these binary variables, we have to leave out one of these groups. So we can run 1 or 2, it doesn't matter which one we run, it's just going to change the sign on this parameter. But we couldn't run this third regression because of this perfect multicollinearity. We often call this the dummy variable trap when it comes to these binary variables. So these binary variables are often called dummy variables, or they used to be called dummy variables a lot. And so perfect multicollinearity, when you encounter these kind of binary variables, is just called the dummy variable trap. So we have to leave out one of the groups. And this group that we leave out becomes our reference group. And then all of the interpretations we're going to make about these parameters on the group, so on female. So let's look at this first regression. So it's, we have a variable that equals 1 when it's female. That means the reference group is someone who doesn't identify as female, and the interpretation of this delta 0 is going to relate to this reference group, and we're going to talk about that once we erase the board. So we have to leave out one of our groups, and this is going to be the reference group. So let's erase this board, let's write out a regression and think about how we interpret these variables now and how it's going to all relate to this reference group. So let's talk about interpretation now. Interpretation. This is when we have a binary variable as one of our x's or one of our independent variables. And so let's say we ran a regression and we found wage. So we ran a regression, that's why there's a hat, because it's estimated. And let's say this is hourly wage. So we want to be able to use the right units here, of course. So that's the intercept. Then we have minus 1.81 female plus 0.572 times education plus 0.25 times experience. Let's say those are our three x's. We have a binary variable set equals 1 if identify as female, 0 if not. And so let's think about what this parameter estimate means. So let's saying delta hat 0, I guess, equals minus 1.81. So we need to think about what that means. And the interpretation is going to be based on the reference group, right? So we should figure out what the reference group is. Well, the reference group is the group we're leaving out. So that's people who don't identify as female. And so the interpretation here is that holding experience and education constant, so years of experience and education constant, someone who identifies as female earns, and I guess it's going to be on average, and I should say is estimated to earn, I should say, on average $1.81 less per hour than someone who does not identify as female. So notice that this interpretation relates to the reference group, right? People who don't identify as female. So holding experience and education constant, so that part of the interpretation doesn't change. Someone who identifies as female is estimated to earn, on average, $1.81 less per hour than someone who does not identify. Someone in the reference group, which is someone who doesn't identify as female. So that's how the interpretation works here. You could do the same thing theoretically. All we're doing is, we're getting rid of the estimated, and on average they earn delta 0 different. That's the difference between their earnings of someone who identifies as female and someone who doesn't. So the key thing here is that the interpretation is against the reference group for these dummy variables.